Thank you very, very much. I guess I would like to say good morning, good afternoon, or good evening, depending on where you are located. My name is Maurice Kavlak, and I'm providing these Fast Lanes webinars about Google Cloud together with my colleague Harald Haas. This is actually the third part of the webinar series about Google Cloud. In the first one, we covered Google Cloud Identity. The second one was about managed Kubernetes, which is called Google Kubernetes Engine in the Google world. And today's session is about Google Cloud Security itself. So what we will cover today is basics about Google Cloud Security. So what is referred with it, or what is meant with Google Cloud Security, which covers a little bit of network details, especially when it comes to Google Cloud itself. Then data at rest, data in transit, of course, and other Google Cloud services which refer to security. Okay, good. As this webinar is being delivered by Fastlane and basically the speakers here, in my case, Maurice Kavlak, me, let's just make sure we have an understanding what Fastlane is and what it delivers itself. Fastlane is an experienced and actually award-winning training provider with a wide range of training methods, actually, such as classroom training. So you don't have just the possibility of doing webinars, you can do it in person as well, or flex or e-learning wise. Fastlane itself is specialized in the area of cloud cybersecurity, which we have now the combination with cloud security actually, digital transformation and mobility in this case. Since this is not my very first session with Fastlane or delivering Fastlane sessions, I can definitely recommend Fastlane as a specialist for technology and business training, and of course consulting services as well. Good, let's go ahead. So today's session is about cloud security in the Google Cloud world itself. First of all, who am I, or who is talking to you? So your trainer for today is me. I'm Maurice Kavlak. That's me on the left-hand side so that you have a face to the name itself. I'm a certified Google Cloud architect working for the Cloud Pilots, and I'm an authorized Google Cloud trainer in the infrastructure path. I'm based in Vienna, Austria, Europe, so I do deliver these sessions in English as we have it right now, as well as in German, which I had actually today a few hours ago. Cool. Let's continue. I guess a lot of the attendees today have seen this, let's say, part of how is IaaS, PaaS, and SaaS structured or divided. So infrastructure as a service, platform as a service, and software as a service, the three pillars of what you can call cloud computing actually. Why is it important actually for cloud security itself? Cloud security in this matter, in this ecosphere where we are talking about, or where we are right now working in, requires collaboration. So depending on what service you would like actually to use in any of the cloud providers out there, any of the hyperscalers out there, you would actually require some collaboration because parts of the whole stack itself, be it now for infrastructure as a service, is being managed by the cloud provider itself, going all the way up from hardware boot, meaning, okay, which operating system plus the kernel itself, storage, network, and audits. That comes from the infrastructure part. When you look at platform, you would even actually trust your cloud provider more parts of the stack. And when it comes completely to software as a service, you would actually only be responsible for the content and access policies, be it now, for example, in the Google use case, Gmail or Drive. So everything which is covered under the G Suite umbrella. So it's very important actually that you know what parts of the stack do you have to take care of when it comes to securing your application, securing your infrastructure itself. And of course, Google provides you with best practices, templates, products, and solutions when it comes to all that. Now, we are living or we are moving now from a world which was rather simple when we look at the left-hand side, where you had a rather simple architecture with a, for example, three-tier web application, where you have, okay, your user comes from the internet, accesses or hits the web tier, which then gets some business logic from the application tier, and this one is gathering data from a database, for example. When we look now at the modern infrastructure, let's say today with Kubernetes, where you have microservices or you provision a service in one cloud and another one in the second cloud provider, and hopefully most of it, of course, in the Google Cloud itself, you are looking at service mesh, let's say, architecture, where services talk to multiple services, and you would actually need to have some kind of overview of that so that you can control it. If you have attended the GKE session with my colleague Harald Haas, he was actually talking about GKE, Google Kubernetes Engine, and there is a very important part when it comes to, okay, you do have Kubernetes with all your microservices, be it on-premise, in combination with the cloud, for example, with Antas, where Istio plays a very important role where you secure all the microservices talking to each other. There you would have actually identified how hard it is to implement something like that on its own, so without any help or without any service which already exists. Start with a few common understandings in order to understand what or how the Google Cloud itself works. As any other hyperscaler itself has many data centers all around the world, and the terminology in the Google Cloud world is regions and zones. So every pin you see here on the landmark is a so-called region. So for example, the Sao Paulo region, Los Angeles, Oregon, usually they have different names. They are not called Los Angeles, but they are called, for example, US West 123, for example. And in there you have so-called zones. Every pin or the blue filled pin are regions which currently exist, and the white ones which have just a blue border are future regions, so which are being right now built up or constructed. One more is missing here in Europe, somewhere here around the east of Germany, Poland, which was announced just a few weeks ago. And there you would have actually another region in order to select and provision your services you would like to have. The number itself inside the pin, so for example here most of them carry a 3, just Iowa, that's the US Central 1 region, carries 4, has the number itself stands for this number of zones, and each zone is a failover zone or failover region, you can actually say, which means in case one zone drops, it's just the zone, it's not the whole region. So you can actually say a zone is a data center, for example. So when you deploy something regional, let's say you deploy your service regional, you would deploy it to multiple zones, but not just to one zone, in case something happens with the zone, that it still stays available. Good. Now, global network, we said, okay, most of it or most of the traffic will be routed more or less, or that's what we heard so far, via the public internet. Now, that is not the case with Google itself or the Google Cloud in this case. Google is one of the largest network providers in the world and maintains its own submarine cables and land cables. and they heavily invest in these as well. So whenever you actually, let's say, for example, when we go back and you would like to have a service provisioned in North Virginia and in Zurich, and these services need to communicate with each other, they would actually communicate via Google provisioned cables, which means lower latency, of course, which means safety as well and security, because Google controls where the traffic goes to, where the traffic is routed. So it's not going to be routed over an unsecure network, for example, but just over the Google network. That is being referred as a premium service tier, but you do have the possibility to deactivate that as well. So you would actually say I'm not willing to do that, or I don't want to do that. I'm gonna downgrade to a standard network tier, and then it would be routed just over the public internet. It would not take the shortest route over the Google network itself. Yeah. Now, most of the companies itself out there right now have still on-premise data centers. And most of the companies we have, or as I'm working as a cloud solution architect, most of the companies itself ask for, in first place, a hybrid cloud scenario. So how do I make it work that my existing infrastructure connects with the capabilities and possibilities the cloud itself delivers? Now, in the Google world itself, you do have 4 to 5 options depending on how you look at it. But the first one would be actually to use the public internet itself, where you would establish a VPN between your on-premise data center network and the Google Cloud network, where you would say, okay, I'm gonna dedicate a VPC, a so-called VPC, which means a virtual private cloud within your Google ecosphere, and this one would connect to your on-premise data network. Or you go the way with a dedicated interconnect, which would be actually a layer 2 connection with a Google data center POP, so point of presence, where Google actually sits, and somewhere in there you would actually, or somewhere close by, you would actually need to be as well in order to establish that layer 2 connection, which enables you to use a private space RFC 1918 address space. So you don't have to provide or to use any external IP addresses which are accessible by the public internet, which then in case you go that way, you get a dedicated bandwidth with an SLA attached to it, of course. Dedicated bandwidth in this case means you can just order links or slots in 10 gigabits slots. So you can say I would like to have just 1, 2, 3, 4, 5, 10 gigabit slots, but it all starts at 10 gigabits. This way, actually, you lower your GCP egress costs. In order to understand that, you would need to know that traffic which goes out of the Google Cloud world. So for example, you do have a service provisioned in the Google Cloud world, and you would like to use, for example, let's say a Slack API, traffic which goes out of the data center itself, so from Google out, is being charged, but not traffic which goes into the network itself. So in case your client wants to use or makes requests to your services which are hosted in the Google Cloud, you don't pay for that traffic actually. So ingress is free of charge, egress costs money. The third or fourth option is actually the way of going or to use a direct peering or a carrier peering. The difference between a dedicated interconnect and the peering options here is interconnects are layer 2. The dedicated interconnect exists as well as a carrier interconnect, so you don't have to connect to a Google point of presence, but you can connect to a partner point of presence as well, which then links back to a Google data center as well. Interconnects, as said, are on layer 2. Peerings or direct peering and carrier peering are a level 3 connection or layer 3 connection, sorry. So they utilize actually existing BGP route selection and internet routing. Of course, carrier peering might offer lower requirements which can be met rather than direct peering, which are then requirements made up by Google itself. Of course, pricing as well as SLA comes by a carrier peering as well as by a carrier interconnect from the partner and not from Google. So how does that work? Or interconnecting networks, the easiest possibility and which most of the companies right now out there take. Of course, it depends all on the traffic you would like to exchange between these two sites, but most of it is covered when you start actually with a Cloud VPN, where you just go ahead and set up a cloud router in the Google Cloud world, which then exchange via BGP as well routes, and which enables as well the cloud router that you actually dynamically enable subnetworks as well, so you don't have to shut down the network and start it in case you would like to add a new subnetwork. This would actually go via IPsec IKE version 1 or 2. Yeah. On the on-premise side, actually, you would need to have a static public IP required. So dynamic IPs, no go. On the Google Cloud world itself, you can always go ahead and say, okay, I would like to reserve a static public IP address. Now, the dedicated interconnect, as said, is a connection between your on-premise network on layer 2, where you would say, I do have an ASN, I do have multiple ASNs and multiple on-premise routers, and all of these would actually map or connect to a Google peering edge, where you do have cloud routers set up. Now, in this case, you can see that you don't have a single public IP address attached to any service. So you're talking just over private IP address spaces. So the traffic never hits actually the public internet in this case. Now, direct peering versus carrier peering, as said itself, you do have customer location. In this case means on-premise simply. You do have one or multiple on-premise locations, which you then connect either via direct peering, where you meet Google requirements in order to connect on layer 3, or on the right hand side you say, I would like to have, or I don't meet all Google requirements, but I do meet requirements which are made by a carrier, for example, which connects to Google. Then you can go the way on layer 3 again and do a carrier peering. Yeah. Carrier interconnect, on the one slide which had 4 options, you didn't see a carrier interconnect. It just said dedicated interconnect, but you do have the possibility to go the way of a carrier interconnect as well. Might be cheaper, but might differ from a SLA perspective as well, where you would say, okay, I'm not close by a Google point of presence, but I'm close by a carrier which then connects to Google. So you can go the way, okay, layer 2 connection to a service provider in this case, and this one then connects to Google. A very common carrier or a very common service provider in this case is Equinix, but everything is documented itself on the Google website, so you can go ahead and say, okay, I'm sitting, for example, somewhere in Munich or in Los Angeles, and you can select, or it lists actually all the providers there. Here we have a short comparison of the connectivity options itself. So which one actually gives you an SLA, how much it is, or how much does Google charge for it, and which one actually gives you the possibility of using private IP address spaces or RFC 1918 addresses. Yeah, the first differentiation is made on a service provider. Everything direct and private. You don't have a service provider in between, but you do have for a carrier and partner interconnects in this case. If you would like to have direct peering or carrier peering, so all peering option requires, or more or less require, an ASN. Public IP required for direct peering, yes, of course, because you go over the public internet, right? Private interconnect, no, not supported even. So you're just using private IP address spaces and so on. If you would like to use direct peering but use private IP address spaces, you would require a VPN to set up. And here it says all services which are then basically in the Google Cloud available in case you go the way of one of these connection options. How much is it? For direct peering and for carrier peering, it's free of charge itself. On a partner interconnect itself, of course, it depends on the partner you choose. So which service provider. Google itself, for each link, charges 2.5K and gives you an SLA of 99.9%. The SLA, of course, on a partner interconnect itself depends on the partner in this case. Good. Next point would be firewalls. As firewalls, in the matter of, you know it from more or less on-premise data networks, you do have the very same, or let's say a similar approach in the Google Cloud world as well. Firewalls are always there and they are attached to so-called VPCs. A VPC is a virtual private cloud, which you can actually say is your network where you would like to provision resources. Resources being, for example, a virtual machine. Now, the default setup itself is that egress, so outgoing network traffic, is allowed, so that's by default. And for the other way around, ingress is the default blocked, so no ingress is permitted by default. Of course, you can go ahead and set up custom firewall rules depending on what your requirements are, but we will actually see how that works in the Google Cloud console once we are done with these slides. Firewall rules. I said you can attach or you can create your very own firewall rules. You do have two types of rules. So you do have ingress and egress rules. As we said previously, you have ingress traffic, you have egress traffic. And you do have the possibility to say, okay, I would like to allow or deny this specific rule. And I can say, or I can filter actually in case it's an ingress rule on IP range, on subnetwork source tag or secondary source. We'll see that options afterwards. And the same one goes actually for the egress as well. Allow, deny, and the destination should be, for example, an IP range or a subnetwork. In the Google Cloud world, you do have other options, not just on IP addresses and subnetworks, as we do have it here, but you do have the possibility to filter traffic based on tags or based on service accounts in certain scenarios. What are tags? You can actually say a specific virtual machine is, for example, a web front-end machine, and you can tag it that way. So you can say, I would like to attach a tag to that machine, which is a web front-end machine. So web front-end tag to that machine. And in case I create all these network rules, then I can actually say, I would like to filter based on tag. So that works within a VPC as well. Now the second option is by service account. So that is a very specific case which is in GCP or in the Google Cloud platform. If you have attended my session about Google Cloud Identity, the very first one, you would actually know that a service account is an identity for a machine. So in case a machine wants to authenticate to another service, they would actually use service accounts for that. Good. Firewall rules. Good. Data at rest and data at rest encryption options. So by default, everything you do in the Google Cloud world is encrypted. Now it depends how much management or how much control do you want to have on your side. So how fine-grained your customer controls should be. Now, If you start a Google Cloud project and provision machines, go ahead and don't bother at all, you would actually be on the left-hand side. You would actually use the default Google Cloud encryption processes and algorithms. So that means everything is automatically encrypted prior to being written to disk, for example, in this case. Each encryption key itself with a set of master keys is encrypted as well, and all the policies are attached to that. So when it comes to key rotation and so on, you don't have to deal with that at all. Then you have the second option, which is called CMAC, so Customer Managed Encryption Keys via Cloud KMS. So you would actually store keys in a Cloud KMS where you do have the key to the Cloud KMS only, and you manage actually which keys are in the KMS. So you are managing just keys. This option actually doesn't is or isn't supported by each service in the Google Cloud, but the services are being more or being upgraded more and more to support that, where we'll see a comparison between these three possibilities soon, where you do have a little more overhead, or let's say not overhead, but a little bit more management tasks to do. And then on the right hand side, you do have customer supplied encryption keys, which means you are storing the keys, you are creating the keys, in you are in full charge of managing these keys. So that means whenever you would like to have keys exchanged, for example, because you would like to change keys every half year, you would need to go ahead and say, okay, please encrypt the data first, decrypt the data first, and then encrypt it again, because I have new keys. And you would need to manage all that, of course. Now, that's absolutely legit, of course. Now, in case you lose these keys, all data will be lost because Google doesn't know anything about your keys in this case. So when we are talking about, or when we are comparing all these three options from a key management effort perspective and from a data encryption effort perspective, you would actually see that the easiest way, of course, is just going ahead and using the default encryption by Google itself. So you don't have any effort when it comes to key management. So where do I store all these keys and so on? And then don't have to do anything when I want to encrypt it because it's encrypted by default. And key rotation is being handled for you or is being managed for you as well. Now CMAC, so customer managed encryption keys, where you store your keys in a KMS, which is supported currently by BigQuery, which is a data warehouse solution in the Google Cloud world. GCE, Compute Engine, which is provisioning of virtual machines in this case. GCS, Cloud Storage, which is a blob store. And Dataproc, a managed Hadoop service in the Google Cloud. From a management perspective itself, you do have, of course, some tasks to do because you do have to store the keys in a KMS, you do have to unlock your keychain and so on whenever you want to read a key. But from an encryption perspective, it's still low, right? Now, when it comes to key rotation, which means, okay, I don't want to use one single key, or I don't want to use one key for 2 years. I do want to change it months, every half year, for example. I do have to handle my key rotation or key rotation process as well, which means now since I have a new key, the old key will not be valid. I do have to decrypt first my data with the old key and encrypt it again with the new key. Same one applies to CSAC, so customer supplied encryption keys, which are now supported by GCE and GCS. So from a key management perspective, of course, it's higher because you do have somewhere to store the keys in a safe way, of course. And the same thing goes for the data encryption effort. You have always to supply the key you would like to have the data encrypted with. That is data at rest. Data in transit itself, of course, depending on what what your service supports. So HTTPS, for example, it's anyways encrypted. If you provision a service which is HTTP, so plain HTTP without any encryption standard behind, it's being non-encrypted. So it's up to you to provide, of course, if you're not on a software as a service side, so in the G Suite itself, which is of course then in transit as well encrypted, but it depends on your data it depends on your implementation of the service. Sorry. Good. Now we will jump to a few services which are actually provided by Google to make your applications, for example, safe and secure. One of them is the identity-aware proxy. The identity-aware proxy is an easy solution actually to set up in order not to implement authentication options for your services in the backend. Now let's assume you do have an ERP or a CRM, for example, in this case, which are sitting, for example, on virtual machines in the Google Cloud. You can set up an IAP, so an identity-aware proxy, which will take care of the authentication of users. Now, how does this work? The identity-aware proxy will go ahead and, depending on your configuration, of course, will terminate HTTPS connection and check for the valid authentication parameters of the user. Now, what does that mean? We're using here cloud identities. Again, if you have attended my very first webinar session about cloud identity, you would know that you do have the possibilities to set up either groups or groups within groups or identities within groups, where you can go ahead and say, okay, I would like to have these two backend services secured by an IAP where I do have, or where I say, okay, these groups or these identities, for example, are allowed to access these ones. Now that's a very convenient way actually to set up authentication in a central, manageable position within your infrastructure now. And Google will take care of the authentication, so you don't have to provide or implement anything when it comes to authentication and authorization within the application itself, because the identity-aware proxy will take care of that. Now it says here it allows you actually to shift access controls from the network perimeter to individual device and users. That's absolutely right. So you don't set up, for example, firewall rules to control access to these resources, but you do actually check, or there's an application for you checking devices and users. So how does that work, or what is happening in the backend? So you do have cloud identities provisioned within your Google Cloud Identity domain, which can come, for example, as well from your local ADs, or from your local Active Directory, where you do have groups and users managed, which allows you now actually, it says here, deploying policies at scale. That's absolutely right, because when you use groups or groups within groups, for example, you can actually say, you can actually configure the identity-aware proxy once and then just control everything with your group configuration or your user configuration. This allows you as well, it says, what I just said is basically described as well here, apply policy by group memberships. But it allows you actually as well to support 2FA security keys or 2FA authentication methods, so a second factor authentication as well. Because depending on your setup, actually, you would get a Google login prompted where the user has to log in with his credentials, and depending on the configuration of the user or your policy in the organization itself, you can enforce a second factor as well without implementing anything on your own in this case. So you don't have, or there is little to no change actually to support applications in the backend to that. You would actually just configure it in the Google Cloud Platform itself. And as said previously, there is no need to implement anything on your very own. That's a process flow actually how that works. As described previously, the user would actually hit the cloud identity aware proxy when requesting, for example, a virtual machine where your CRM is sitting. Now Google would go ahead and check, okay, is this user already authenticated maybe because he or she is using already a Google service somewhere? In case the user is not authenticated, the user would get a Google sign-in prompt, would log in. You could even have here right now single sign-on activated depending on your cloud identity setup as well. And then it would check authorization rules. So is the user actually one which is allowed to access that resource? Yes, then the user can actually go ahead, depending on, of course, again, firewall rules. This would be the last parameter to check, can the user go ahead? Good. So basically, when it comes from a setup perspective itself, you would actually just simply use whatever you have currently provisioned in a virtual machine, for example, or even in a Kubernetes cluster, for example, and just put the cloud IAP in front of that. In combination to the cloud IAP, so the cloud identity aware proxy, there is something called access context managing or access context manager in this case, where you can say, okay, I would like to apply policies as well, depending on what device my user is using. So in case he's using, for example, an Android device, I don't want to let him in, or I don't want to grant access actually to the service. Or in case he's not sitting, for example, in a location ABC, so he, for example, not in the United States, don't grant access to the services as well. So this is actually called context awareness. What does it say as well? At time of day, for example, as well. So, oops, sorry. You can say, okay, 9 to 5 only. And that is actually possible to say, okay, for G Suite for G Suite services as well as for my GCP services. Now, I have talked about Google offered services or Google offered security services in this case. But you do have the possibility as well to use third-party appliances as well. So you can say, okay, I'm used to Cisco, I'm used to HP security or whatever might be out there on the market, and is supported as well by the Google Cloud, of course. You can actually go ahead and say, okay, I would like to provision a virtual machine or something in the Google Cloud world which is a security appliance, for example, provided by Cisco in this case, be it IDS or IPS, something like that. And you can say, okay, this one actually should be my front-facing machine. And in this case, you would actually go ahead and say, I'm provisioning that thing, and I'm attaching two NICs to that machine. So I'm attaching one network interface card and the second network interface card, which then actually connect to the real networks in the backend where my services are sitting. So you're not just limited to Google offered security services. You can go ahead and use what you are used to or your engineers are actually experts in. Currently, you do have the possibility to say, okay, I want a machine which has up to 8 NICs, but that of course varies by vCPU, which means varies by which machine type you take. And of course, this is being changed depending on the generations Google actually provisions out there. Good. Now, jumping back to maybe a software service or a software security service from Google, in this case is something which is called Cloud Armor, which is a service which protects the user from distributed denial of service attacks and application attacks. It itself works with the Cloud HTTP load balancer, the global one of Google, and supports IPv4 and IPv6 whitelisting and blacklisting in this case. So you might have heard of famous whistleblowers maybe which or who provisions some websites, and Google actually came out with an offer. Okay, we are going to protect you from DDoS attacks, and this service was or is still named Cloud Armor in this case. Of course, you can always take a look, even though you're using a managed service from Google, you can actually take a look at how much traffic or how much traffic is allowed and blocked. And all this information you would actually see in the Stackdriver logging page. Stackdriver, if you haven't heard so far, Stackdriver is a logging suite, or Stackdriver is a, let's call it just suite, which is fully integrated in the Google Cloud world, which gives you logging capabilities, error reporting, tracing, notifying, monitoring, and so on. The Titan chip. So I think we have, or the Google Cloud event is, or the Google event itself is finished now. But Titan was a very big topic, I think, in the one of the last keynotes. And the Titan chip itself is a single chip, which is on every machine or on every server, which is in the which is in a Google data center at all. Now, this Titan chip actually is a Google purpose-built chip. Google itself is one of the largest server manufacturers out there on the world. So somewhere within the top 5, Google sits there, and it delivers a hardware-based root of trust. So whatever is being provisioned in a data center actually can only be connected to other services in case this Titan or this trust is being established. Now, coming from a hardware perspective as well as firmware and software components. So here it says, and this means actually only hardware which is being provisioned by Google in combination with specific firmware and software components can be or can be then offered to a customer as well. And this actually provides a strong system identity. So every machine gets an identity in a data center in GCP. From a Titan chip, you may know it as well, since Google announced that every or almost every new Android device can be used as a Titan security chip as well, which means you can use your Android phone or you can use a Titan USB key, for example, as a second factor as well when you're trying to log in, because you do have a trusted identity in this case. Another thing or another service in the Google Cloud world is a Cloud HSM, so hardware security model, which is being offered by Google, which allows you actually to create keys, import and export keys. Here it says down here. And these HSM modules are actually operated and owned by Google itself. So Google is actually responsible for clustering, scaling, and patching all these HSMs. It offers you as an HSM, it offers you actually symmetric key operations, so you can encrypt, decrypt data, for example, AES or DS with it, or asymmetric key operations, RSA signatures and verifications of signatures, where you can export as well your public key. Good. The Cloud Security Command Center. Now, the Cloud Security Command Center is actually a suite of multiple things being put together, and it itself assesses and discovers inventory you have provisioned in the Google Cloud world. So for example, it lists all projects, because the Cloud Security Command Center itself, when you're familiar with the structure of GCP, on the very top level, you do have an organization node, and down at the lowest level, you have projects where you provision services like machines. Now, the Cloud Security Command Center sits actually on the organizational level and then scans through all the services or all things you have provisioned in your whole organization. So be it, for example, project or one or more projects, GCE instances or compute engine instances, virtual machines in this case, storage buckets, GAE, App Engine, which is a managed compute um, service, and data store like Firestore, so a NoSQL database. And as well, it would scan for PII. So if you have sensitive data, for example, in cloud storage buckets, then it would say it would identify these as well as data store kinds. Another possibility or another capability of the Cloud Security Command Center would be web app vulnerability scanning, where it offers cross-site scripting vulnerability scans, or it would even mark insecure libraries if you're using some of these in GCE, Compute Engine, or App Engine. So these notifications, in case something is being discovered, you can actually say, okay, I would like to have these exported or integrated to PubSub. PubSub is a messaging service offered by Google, similar to Kafka, but not to the whole extent Kafka does, where you then can build logic around that. Event threat detection itself is another service offered by Google. So what does event threat detection does? So it automatically scans structural logs for suspicious activity in your Google Cloud Platform environment. What does it do? It applies actually machine learning to your log data, which is being present simply since Google offers a logging suite like Stackdriver, where you can say, okay, I would like to go ahead and say this, or Google does actually with machine learning algorithms say, okay, this is actually something which is not very common and somehow suspicious, so I would, or this needs to be informed, this needs to be notified, or this needs to be somehow visualized to the user. So that's ETD in this case. Security health analytics is something which is sitting again in CSCC, so the Cloud Security Control Center, and it actually is a managed vulnerability assessment scanning for GCP. So you can actually say, or it would actually define, or it would detect common vulnerabilities and misconfiguration across. So maybe you have heard of in the past in the newspapers that PII data was identified on a bucket on a different cloud provider rather than not Google. And it was just simply accessible via the public internet. Most likely you would, or Google would have warned you about that you have a public bucket. Public bucket means every user which has the link to the bucket can access this one. And you would actually see this misconfiguration because a public bucket is not a vulnerability, it's rather a misconfiguration on your bucket itself, so on your storage. Of course, Google offers as well a cloud security bulletin where every CVE which might or which affects Google as well. So in case Intel processors are somehow affected by a CVE, you would actually read or you could read that as well in the security bulletin web page. I talked about Stackdriver, or I've mentioned Stackdriver. Stackdriver is not just there that you can log data information or that you can log service information, but it logs as well administrative activities done on the Google Cloud Platform. So in case somebody changes configuration, this is actually covered by the access transparency paradigm in Google. It would say, okay, this this or that happened and was actioned by user XYZ. So you can actually verify and track actions taken on your project or in your Google Cloud ecosphere, which gives you the possibility to audit that as well, of course, in case you have legal or regulatory obligations. Now, in case now you do have, or you're managing most of it actually on your own, of course, because you are the cloud customer and you would like to don't want Google to check anything, or you don't want even Google to take a look at your data because it's not possible at all as well. But in case you are at a certain point where you can't actually continue or you don't know what to do anymore, you could actually request support for Google that Google actually gets access to your data as well because you don't know what to do anymore. Now, in this case, there is a certain process established around that as well. So it's not just, okay, I'm going to write an email to Google and say, okay, you can access my data. There is a process around that which says, okay, access approval. So you would actually approve somebody taking a look at your data first. Good. Another thing is the DLP API, so the Data Loss Prevention API in this case, which provides you actually a programmatic access to, it says here, to a powerful detection engine for PII data. In the backend as well is strong machine learning algorithms which identify data which might be PII data. Of course, you do have to set up first or configure DLP, data loss prevention. Which data do you want to have redacted? For example, here in this case, it's credit card data. So I do have the possibility, of course, of reduction. So just reduct the data, or I can hash or tokenize the data, or I can even preserve the format so it looks similar to a credit card number in this case. And of course, it's not just bound to credit card data. You can actually say, go ahead and say, okay, my data might contain telephone numbers. My data might contain addresses, which I don't want to have stored in my database. Use case would be, for example, you do have a chatbot where users put in data which might not be even necessary to, or which might not be necessary for you to solve the case. So you don't want to store the data at all in your database because it might get problematic at some point. You do use the data loss prevention API to supply the API with the request or the input of the user. The API itself redacts information from it, and then you can store it, for example, in a database. Now, a few weeks ago, Google itself announced the IAM Recommender. What is the IAM Recommender? So Identity and Access Management. When it comes to that, we have discussed it as well in the very first webinar about cloud identity. So when you grant users or groups roles and permissions, you might do that in a way which is not applying the security principle of least privilege. So you might over provision roles for certain users. Now, what would the IAM Recommender do? Over a period of 80 to 90 days, it would actually check the user which services is the user or the account using in the backend or is using during the day-to-day operations. And within this period, it would actually check and recommend after the 80 to 90 days. So it says here analysis is based off of the last 88 days. It would recommend then to remove certain privileges, so certain permissions, because the account is not using that. So you can actually apply or you can actually conform to the security principle of least privilege. So you can actually just provision roles and services or permissions which are really needed for that account. That means as well you minimize the attack surface to potential attackers. That's about the IAM Recommender. This service is so far, I'm not sure right now, either alpha or beta, so it's not GA as far as I know right now. Another thing is Apigee. So Apigee is or was a company which Google acquired a few years or months ago, not sure right now. which is all about API management. So I talked about IAP, which works with Google Cloud Identities. Now with Apigee, you do have the possibility to set an API facade in front of certain services, which then gives you the possibility to authenticate and authorize users based on tokens, based on whatever you actually want to have implemented. And this would actually be Apigee in this case. Okay, good. Anything else I would need to add here? So Apigee in this case is just another service which can be sitting in front of other services you would like to have secured and not implemented directly in your logic, in your code. One more thing maybe to Apigee, it's not just about API security. I said it's all about API management. It gives you the possibility, or it delivers the possibility of API monetization as well. Good. The last topic on my slides right now, since we are already at the top of the hour, would be penetration testing. So if in case you would like to go ahead and test your very own provisioned services or provisioned infrastructure in the Google Cloud world itself, you don't have to notify Google, because some people think, okay, I wouldn't need to notify Google that I'm running tests against my own infrastructure. No, that is not the case. Of course, you are only allowed to do that against your very own infrastructure, and only people people who the company engage with should do that as well. In case you found, or in case you find a vulnerability which is generic to, or which might be generic to other users, of course, you can then report these via the vulnerability reward program, so the bounty hunting program. That's about it when it comes to the slides. Now, are there any questions? As said, there is a Q&A section. I'm just going to check if I can find some questions. So there are no questions so far. The next thing which we will continue right now is to go just into the Google Cloud Console and take a look at the services. I do have a question from one of the attendees. Can you please share the slides with us? I will check if I can share the slides with us, with all of you, of course, and afterwards, because I don't have the contact information right now, but I will check with my colleagues, of course. Cool. Thank you for that question. If there are any other questions, just let me know or type them in, please. And other than that, I will go right into that a little bit to the side. I'll go to the Google Cloud Console. Let us start with where would you find all these network options. So we said we do have two network service tiers. By default, you are always on the premium network tier, which means every network traffic will be routed via the Google provided network, so via Google dark fiber and Google undersea cables. You can actually downgrade as well to a standard tier, which then means, or Google likes to refer to that as hot potato routing and cold potato routing. Other cloud providers are a huge fan of cloud potato routing, which means, okay, does it belong to my network? No, I will just put it out to the public internet. In case it belongs to my cloud traffic, then I'm gonna route it over my network. Google is not doing that. Google is a fan of cold potato routing. In case I have a fast route for that traffic, I'm gonna route it over the Google network. Nevertheless, if you would like to have that changed, you can change it here. So you can jump back to the standard tier. And as well, it says, okay, that you do have a recommendation possibility, which network service tier is the right one for me, for example. Cool. Then we said, okay, all these topics about interconnects, VPN, direct peering, carrier peering, and so on, they are covered here. The hybrid connectivity menu, so you can go ahead and provision your VPN here, create a VPN connection where you would actually set up all the configuration options. And the interconnect would be here, so we can say, okay, interconnect. Do I want to have a dedicated interconnect or a partner interconnect? Go ahead and say continue. You can say order a new dedicated interconnect, or I would like to attach, or I would like just to have a new VLAN attachment to an existing dedicated interconnect already. Let's say continue or new. Of course, I'm not gonna make it to the end. But as said, you can just order it in a 10 gigabit way. So you can say 10, 20, 30, 40, and so on, and up to 200. Okay, I'm gonna cancel that right now. Hybrid connectivity. Here you would find actually the cloud routers as well, which are required for a interconnect in this case. Here you would have other topics as load balancing, DNS, CDNs, network address translation. But let's come to VPCs. We said, okay, VPCs are networks where you provision services in your Google Cloud world. Now, by default, when you create a project, so we said, okay, projects are something living where you provision services in, so where you say, and where billing is happening. And in a VPC, you would actually provision virtual machines, for example. Now, a VPC itself is a global construct. So a VPC stretches over the globe actually, and then you have subnetworks. And subnetworks are something regional. So subnetworks, the US Central 1 subnet in this case, stretches over the region US Central 1 and has a dedicated IP range. Same goes for Europe West 1. We said regions are something which covers multiple zones. Multiple zones, one zone being, for example, you can say one data center. Now we said external, in order to provision on VPNs, you would actually need to have static IP addresses. In the Google Cloud world, you can reserve here a static IP address, be it now an IP version 4 or version 6 address. You can provision these on a premium network tier or on a standard network tier, and you can choose the region, of course. Static IP addresses not attached to an instance, so not attached to a virtual machines, are built on at an hourly rate. So you can check actually the pricing rates, how that works. Now let's go back to firewall rules. So remember we said, okay, when it comes to network traffic, default ingress is denied, so no ingress traffic is allowed. By default, all egress traffic is allowed. So here it says, okay, I do have right now 4 firewall rules. All of these are ingress because, as said, default ingress denied. In order to allow, for example, SSH connections, RDP connections, and ICMP packets, I have firewall rules established actually to allow these. Now, for example, let's take a look at the ICMP rule. It says, okay, I gave it a name, allow ICMP from anywhere means global internet, public internet. Anybody can actually, in case knows the IP address of a machine I have provisioned, maybe can send ICMP packets. Of course, if the machine in the backend supports ICMP or has ICMP activated, let's say. The network itself to which this firewall rule is attached is the default network and has a priority. So I can overwrite or I can overrule actually firewalls with each other. So I can say the next firewall rule, which has actually a priority which is lower than this one, would overwrite this one. And yeah, That's what I wanted to say actually, but let's go back maybe and check more things. When we create a firewall rules, when we create a firewall rule, you would actually see that. You can turn on logs as well. So by default, every logging capability when it comes to firewall rules is deactivated. You would actually need to turn these on. Here you would actually have the possibility as set to which network should this firewall rule be attached to. Then you would have a priority. So this one has a priority of 1000, for example, if I would create one. You would select actually the direction of traffic. So is it ingress or egress you would like actually to have controlled? What do I want to do? So what's the action with the traffic? Do I want to allow or deny? And then we actually go with the target. So when we say, okay, it's ingress, so traffic coming into my cloud, should the target be all instances in the network? So simply, should it affect every instance which is in the default network here? And what should be the source filter? So if I say deny, for example, and I would like to have addresses 17.15, I don't know, 118.14 slash 20, for example, and I would like to have them denied. Every request which comes from an IP address which matches this IP range would be blocked, for example. Of course, we would actually need to supply a valid IP address side range. And we can apply as well secondary secondary source filters. So we can say, okay, it should not be just by IP addresses, but we can actually select, for example, source tags. As said, in the Google Cloud world, you can attach tags to virtual machines. Be it now, for example, I do have a virtual machine tagged as web frontend, as said. Now I can say, okay, every web frontend machine can talk to a backend machine and not vice versa. And the last part would actually be, for example, ports or protocols. So I can say, okay, TCP protocols and ports or other protocols here. Cool. That's about networks and networking. Now let's jump into security here. So the security tab. Now I said the security command center itself is a global construct. It's not something which is on a project level, but it is on the whole domain or on the whole organization. So let's jump into that. Cool. I said the security command center scans every asset or scans everything you have provisioned within your organization. Now let's go to that. That would be actually in here in the assets, which you can right now filter by the asset type here, for example, or we can actually say by the project itself. So I do have a few projects here, and I can go into one and check what is provisioned in order to have some kind of an overview what is happening within my organization. Now the same thing goes right now when it comes to findings. Luckily, we don't have any findings in here, but vulnerabilities, of course, in case or just to have something showable right now here. So Google would, or the Google Cloud Platform itself would actually highlight you that something is not configured right, or something which is, or something which could be done better or more secure in this case. For example, in here, so you do have virtual machines which have public IP addresses. This might not be something you would have thought because you do have, or you might have checked the box which you didn't want to, and now your machine actually is accessible by the public internet. This here, for example, automated backups should be enabled. So in case, of course, your machine or your service goes down or something happens actually that you do have backups from which you can restore services again. Then we said one more thing, the IAP. The IAP itself is something which is not on the organizational level. So when I go back to my project, the GCP architect, identity aware proxy, I would, let's go into here. Same one goes actually for the web security scan. I would just need to refresh one more. Correct. So I can actually set up a web security scanner which would scan certain URLs I define here on a regular basis, for example. So I can go ahead and say schedule on a daily basis, weekly, bi-weekly, or 4-weekly basis. And please scan this web app against certain against vulnerabilities. You can provide, of course, authentication options. So you can say, okay, I would like to use a Google account, or I would like to use a non-Google account. Of course, you would first need to supply the sign-in page with the username password. And then you can go ahead and you can actually say, okay, export to Cloud Security Command Center. So whatever the web security scanner finds would be exported to the Cloud Security Command Center. So you would actually find it here. Data loss prevention API can be found here. I may have not activated the API, of course. I can enable it. So I can actually then go ahead and say create a job or a job trigger in this case. As said, the DLP, the data loss prevention, needs a configuration attached to it. So what data would you like to have extracted? IAP, identity aware proxy, which I'm a huge fan of since you don't have to really implement any authentication options within your application itself. You just go ahead and use IAP. So here you would actually have the possibility to select a backend service, be it now a virtual machine or an app engine in this case as well, which will then be secured by the IAP. I would then go ahead and just on the right hand side, once I select the service, for example, on the right hand side, I can just go ahead and say, okay, please add this group or this user to the authenticated, let's say, users who may access my service in the backend. Well, if there are no questions, then of course, thank you very, very much for your attention again. And I hope to see you in one of the next webinars. And I hope, of course, that this webinar met your expectations you had in the session itself. And I would be happy if you join us again next time. I do have, of course, a few recommended trainings, which I would say you could or you should do with Fastlane together. One of them being security in Google Cloud Platform. The code itself is SGCP, which can be found on the website flane.de /en/google-cloud. Or a more generic topic would be networking in Google Cloud Platform and GCP. And yeah, of course, follow us on social media, and I hope to see you again or hear you again. Thank you very much again, and wish you a nice evening, afternoon, or still morning if you're somewhere more or far away.